in the world ranking. So what research we are doing is bringing up a lot of value over the environment, over the climate, and itself, like of course the research impact is there, and then the financial impact is also there overall community and the environment. So the research value that I want to highlight here is very notable, around 700 million total research income alone this university is doing in Australia. 1.7 billion invested in the research in 2024 and beyond onwards. So the research is an integral part of the Monash University, all the campuses, and we pay a lot of strategic planning. We pay a lot of attention towards the research and the things. So what we are actually challenging here in this part, the prominent challenges we are facing here in this era is, and we in the Monash are working on these ones, are like top 3 I can mention here. The climate change is the first one. This is the first most challenge that the university is handling on its research level. Geopolitical security and the thriving communities are the second and the third respectively. These are also being taken in the high impact areas within the research strategic plans here. And the environmental and the social impact is also being mentioned. So from 2025, we are switching to 100% renewable electricity across the campus. And since 2015, we've cut our energy emissions intensity by 74%. So green energy and avoiding the CO2 emission, and is one of the primary objective and aim here at Monash as well. So moving forward now, so that was a quick intro about the Monash. You can definitely go into the detail through the websites that are and other portals. Let's talk about the vision to velocity point, how we are bringing up the concept of the electric vehicle traffic and the intelligent processing of this traffic into the intelligent insights is here. So I will start the point to identify how we are moving towards a data-driven system. As I said, this will be my main point of talk here. We do not see the cities as they are just evolving with the chaos and with the traffic and with everything around us. At the moment, the requirement of the era is to see the cities, to see the everything that is involved in the city as a kind of an intelligent data input. And the type of the point that I am targeting here in this area is the traffic. And in the traffic, again, there can be multiple things that we can target, but I am targeting about the electric vehicles at the moment. So once we talk about these smart cities, there are actually a whole big paradigm that we can target. It is a big umbrella, right? Having a point of focus is very important. What things are driving the data in the smart city environments? I identified electric vehicles. Most of you are working on some, I believe so, in the other different directions, other different point of inputs and the data points. So, but everything is at the end collecting together to bring it in the smart environment, right? That's important, that how we integrate the things mutually. Let's talk about some problems that exist here in the smart cities with respect to the traveling point. So the traffic with respect to the EV, just keeping the EV in mind, the traffic exists, right? We are having the chaos around us. We can see the traffic around us, but are we able to utilize this whole chaos in some intelligent manner? Are we able to identify the patterns in this traffic? Are we able to monitor and identify the future trends or something in this traffic? So the real-time understanding is a point that is missing. To identify a pattern-based analysis, to do some kind of this analysis, we need to first of all capture the real-time activity in the scene, in the environment itself, right? It can happen through immersion. It can happen through the simulation that I'm going to talk further through the digital twin. It can happen through the emulation as well, to just identify the patterns, futuristic approach there. But the thing is, we need to talk about the real-time understanding. This if it is missing, this is a problematic thing at this current point of time. Now, considering the type of the traffics that we have around us, it's quite chaotic again to talk about everything at one time. It's not possible. So I'm focusing on the EVs, right? Electric vehicles, but then this is not the limit. This is just a point where you can start thinking about some other inputs, data-driven inputs in the traffic scene, right? Anyways, so EV adoption is rapidly increasing, right? We can see the worldwide growth, and honestly speaking, with the recent chaos that is happening in the geopolitical world, in one of the recent news that mentioned that EV vehicles are being sold 500%. Their sales increased 500% across Melbourne in the last week only. So this is showing that the world is now moving towards the electric vehicles. So how to incorporate the intelligent data analysis with these vehicles specifically? Of course, this is a point of concern here. So we'll not take traffic as a chaos. We will try to see the traffic as a living data system. Chaos is everywhere around us, right? The mob itself is a chaos. The traffic, the vehicles, it's the large, if they are in large amount, they are chaotic, right? Even every activity that is happening over the communication platform is chaotic. Until and unless we identify a useful pattern and we use that pattern in some constructive work, intelligent constructive work for the future. So this is the vision that is behind the whole point of using the vision to velocity. So this is, I'm going to convey further. Now, from this point onwards, I will talk about some of the research works that happened under this umbrella. One of these is very prominent, a very credible work that appeared in one of the Core Star conference. This talked about the energy trading system. So within the electric vehicle industry, we can have, again, multiple domains. The point of work in this research was talking about the energy trading, if the vehicles can also be part of the energy trading system or not. So because energy consumption is one thing that we, of course, talk about a lot when we talk about the electric vehicle or EVs, but are the vehicles also able to produce the energy back into the grid systems or not? So we try to work on this phenomena. We identified if this is happening, and yeah, of course this is happening, but we deep into that. We identified the patterns through the dashboard, and yeah, I'll show you a link which you can definitely access for now and interact with this dashboard in real time. So this is a view of how our dashboard, energy trading dashboard looks like. It will show you, it will, like on the dashboard, you can see there is a cost emission inputs and outputs, and the emission, how much emission is reduced is being mentioned. But overall, it is telling us and talking about the cost emission reduction through the spatiotemporal forecast and the smart charging. So this is a kind of an in-depth thing. I'm not going to touch base the low-level working on this point, because I try to make it simple for my audience to understand it. So what vehicle to everything is? So vehicle to everything is vehicles are being part of the whole phenomena. They are bringing up the energy, they are bringing up, they are consuming the energy, and they are reproducing the energy as well to the system. So bidirectional transfer is a point of understanding here. With this bidirectional transfer, we want to see that how, sorry, I just want to open this point apart. Yeah. So with this thing, we want to see the energy transfer is possible or not. And what the EVs are bringing back into the environment. If it is just consuming the electricity, if it is just consuming some kind of the energy and not taking part to give something back to the system, to give something back to its grid, or what? So in vehicle to everything brings the energy back into the system in some way. Now, Okay, so yeah, so there was a kind of a forecasting that is identified in the whole pipeline. There was a continuous forecasting plus optimization identified in this work, which actually brought up the automated energy trading dashboard. The energy is by when the EV is buying the energy, when the energy is bought by the EV, their price and emissions are low, but when they sell, the price and emissions are high. So bringing the energy from the grid to the vehicle and from the vehicle back towards the system or the grid, this actually brings ups and downs, lows and highs, and this forecasting is telling us that how the things are going on into the system. So there is a simulation flow that was created to understand the flow of this energy, like we identified in the form of charging and discharging scheduling. This simulation integrates the mobility, the EV mobility. So EV is moving from one place, household energy being used to charge the EV, and then the electricity market is there to generate the detailed operational data. And then it models how charging, discharging, solar generation and electricity price interact within this whole dashboard. The dashboard data comes from the simulation, which runs for 30 days. As mentioned, we kept the data granularity for 5 minutes interval. And after each 5 minutes of interval, the new data is being captured, and the recent futuristic forecast is being provided in that one as well. Okay. There's something to mention. All good? Okay.
Yes, ma'am.
Yes, ma'am. All good? All good. All good. Okay. Okay. So this dashboard demonstrates our work on the residential households. This one is telling us how the residential households can reduce both energy cost and carbon emission. And this one actually on the lower level side of the working, it leverages the spatial temporal forecast of energy, mobility, and the solar data combined with the dynamic scheduling as mentioned over here. So if you want to know more about this working, you can scan this QR code. The live demo is there available on our server, and you can check how it is working. You can see the dashboard, how is it working by itself. So the features, as mentioned here, we fast forward through and jump into the specific simulation states. I mentioned the 5 minutes granularity was maintained. The visualization using the spatial temporal techniques, and as mentioned, current energy mobility states were identified. We are able to compare the charging and the discharging actions across the different strategies, and we can visualize the EV mobility trajectories, of course, on this dashboard as well. We are also able to do the calculation over the cost and the emission reductions as well within the environment, and we can also track the cumulative cost and emission accumulation over the timeline as well. So yeah, I would like my audience to please go into this detail and check how this dashboard is working. This is one of the area that I wanted to touch base. And the next one is kind of an algorithmic working where we can use some deep learning algorithm to identify the traffic model or traffic flow pattern or something like that. It can be used in multiple ways, but I'll touch base one of the work that we have done here. So we have used the YOLO 11 actually to work with this moving object detection and trajectory pipeline. So YOLO 11 is one of the very mature algorithm in this area. A part of the different versions of the YOLO, the 11 one is we use the 11 one because this is a recent one. There are many pros and cons behind the use of YOLO 11. I'm not going into the detail, but yeah, I'll recommend you guys to go into this one. So here you can see this is a traditional MOT pipeline, the monitoring of the vehicles happening through the smart cameras. If the edge devices are being used at this part, we are deploying one of the algorithm that says YOLO 11 has been identified, and then we are able to identify the vehicles. So the classification of the vehicles can be done through the YOLO 11. This can be improvised, that what we have done actually. So the external trackers, if are there, and the multiple scenes, like again, the granularity is there, maybe a few seconds. So with every few seconds passed, we identify the vehicles, we classify the vehicles that are there, and finally we create a trajectory computation of the vehicle over across a kind of the road. Okay, so at the travel plane, we can identify that trajectory, right? So once we were working over this YOLO 11, we were implementing it there, we identified that it can be improvised if we want to signify the latency, if we want to delay, if we want to reduce the delay in the whole trajectory, in this trajectory computation, if we want to reduce it, and how to do it. So there is one method that was identified by our work. This is a use of joint detection and embedding work. And this JDE jointly performs the object detection and identity representation learning within a single network. So because this is a deep learning module, deep learning algorithm, we are working with the JDE on single network here, and we are eliminating external trackers in this work as well. So working with the JDE, we are able to actually detect and re-identify at the same time. So we are basically reducing one of the stage in this part. So we are detecting and embedding at the same time. So overall latency definitely has been reduced because of this work. And yeah, so this was the objective behind working to build an end-to-end vehicle detection for the tracking and other things. Research question is identified. The gap was very important because the existing JDE-based methods are predominantly studied for pedestrian tracking only. However, we tried to work with the JDE for the I meant to say the vehicles itself and the traffic. So we tried to work with the vehicle tracking scenario. So this was one of the work that I wanted to mention here. A bit of the architecture overview of this work is mentioned here in this slide. So the YOLO 11 architecture is identified with this one. The detection itself is being made here. So we used this part of the algorithm and we modified it through the working. So detection and embedding and identification is embedded together at the same layer. Yeah, of course, the details are there coming up in our future paper. So yeah, this is what I wanted to mention. But next part is very important. Until here, we are doing some simulations, we are doing the real-time capturing, and we are able to detect, identify, and record the data in the traffic scene, right? But how to actually bring some intelligent processing over it? It's not really possible to go on the road and do it, of course, manually. So for that one, we need to capture the whole scenario in some emulation environment and kind of a digital twin layer that I'm going to present here. So digital twin is one of the very speculative simulation environment in the smart environment areas. Multiple areas are taking the benefit of digital twin. So why not the traffic monitoring systems, right? So the digital twin layer will actually help us to identify what's happening in the physical city. And it will tell us regular updates happening on the situation, right? If we are able to embed the vehicles information and the digital twin is taking care of individual vehicles on runtime, then we can get the updates and we can speculate the future patterns and we can work on that one as well in different domains. The applications, the real-time applications are very much broad here. This is a very open research question. A lot of research potential is there in this area. So yeah, this is one thing. What live EV monitoring can actually bring up, as I said, there is a research room available here. We can track the EVs for multiple purposes. Endless domains are there, of course. Identified vehicles can be targeted for multiple reasons and then can be tracked. Their trajectory can be identified and computed, of course, and then the future pattern can be identified. And the whole scenario, the whole data that is coming into the system because of any specific, due to the movement of mobility of any specific EV, or through some external data entry points as well in the system. Those can be measured in real time, and of course it can also help in various multiple ways we can see. Okay, so now this overall brings up a kind of an smart system intelligence. We are looking at the data streams that are combined into a dynamic city scale intelligence system. So smart city, there are the concepts of the model smart cities around Australia and other like other countries. I have worked with South Korean researchers on this area as well. So they have made a kind of a model city that is intelligent smart city, where the vehicles are being monitored, mobility of the vehicles is monitored, and the data intelligence strategies and data analysis strategies that are being applied are enormous. So yeah, this is one of the digital twin view of how this actually can be monitored in real time. So I would end my discussion with this point that whatever we see over the screen as a kind of a simulation, and we just think that this is just a kind of a simple simulation for some obvious and some passive reasons. So that's not the thing. That's not just simply a road that we are looking. We need to see it as a kind of a kind of a virtual view of the smart city. So it is a real-time digital twin of the city that we can look, and of course they can work over it with the time. Okay, so final notes. I believe I'm not running out of time, and still they have a room of question answer session here. So we are not just building the systems on their own. The futuristic approach that already is here is we are building the living intelligent smart cities, right? What we see today is just the beginning of what is actually coming ahead in future. Sensing, AI, infrastructure, everything is coming together, and the cities are stopped being static. We need to see how the cities are bringing up the real-time data-driven systems. So this is the future view that we need to look into. I will end my talk at this point. I conclude here. I hope you all have enjoyed this exciting session of this knowledge corridor. Feel free to reach out to me through this email ID. I would love to connect with my audience, and I'm happy to take any questions if there are from the audience right
now. Thank you, Dr. Esma, for presenting very insightful and interesting talk, how AI and computer vision is used to detect and monitor electric vehicles in live traffic environment in the context of smart cities. Now, audience is open for any discussion and questions. Any questions from audience?
Yes, ma'am. Isma, a very nice presentation and valuable insights for your contribution. I have just few questions. First, what challenges did you face when integrating YOLO-based detection with embedding learning in a single architecture?
Okay, so there wasn't any, I would say there wasn't any working challenge here in this point, because the YOLO actually provide us the open source algorithm, right? So that we can actually practice, we can modify it, and we can improve it as per the requirement. So the only thing that was embedded here was related to the identification part. So we use the convolutional matrix. You can see here the additional layers of the convolution neural network was embedded with the current available detection algorithm. And we were able to reduce the latency when the two were combined. Previously, these were being taken in the individual layers, but when we combined the computation in the single layer, then the latency was obviously reduced. It wasn't any, it was not very challenging on the practical level, but the impact, what we see on the physical level is very profound. That was one thing that I can say. Yeah.
Yeah, in this previous, if you move towards the previous slide, you slide highlight the latency introduced by the traditional detection tracking pipeline. Could you elaborate on the key bottlenecks and how significant the latency reduction is with the JDE approach?
This work actually, I'm not able to produce the accuracy results here because we are still under the testing environment. Of course, I present it here after we have found a prominent accuracy and improvement overall in the system. I've not included the result here, but of course, the improvement that I remember so far from our work is very much like from the 80%, it is now being reduced to 70%. So over a 10% difference we have monitored, and that is how we are taking it further.
Okay, thank you so much. Last but not least, I want to mention that, can your approach generalize beyond EV to mixed traffic environment, and what modification will be required?
Of course, like there are wonderful areas that we can highlight. There are not just the EVs. EV was one of the part of the work that I presented earlier, but not with this one. We are targeting every vehicle that can come under the traffic in the definition of the vehicle. It's quite possible that if we become specific to some type of the vehicle, it gives us actually a saturated room to work on that type of the vehicle. And then it is better to identify and then do some analytics on that type of the vehicle. If you keep it very broad, right, every vehicle, let's say, then it's like very chaotic. And again, it is very, it becomes sometimes difficult to identify the motivation behind all type of the vehicles at one scene. For example, if I say now the electric vehicles, so we want to, let's say, analyze the patterns of the use of the electric vehicles, or maybe we want to see how the trajectory is being monitored for the electric vehicles, because it is not really much popular if we compare it with the traditional vehicles. So this is one of the motivation behind the use of the EVs, but definitely there can be other. One of the things that I can mention is the use of some life-saving vehicles. This is something that I'm working with my other project. So monitoring the flow of the life-saving vehicles in a rush environment, in a chaotic traffic scene, and how it is giving the space or something. That is one of the work that we are doing through the YOLO. So yeah, there are enormous working areas that we can do in this area. Yeah.
Thank you so much for your valuable insights. Best of luck for your research.
Thank you, Dr. Ali. Thank you so much.
Dr. Isma, we have one question from Dr. Tayyab. Dr. Tayyab, please ask.
First of all, I really appreciate your effort. Here are some construction activities in progress, so I can text the question. So please respond on it.
You will send me over email. Sorry if there was some thing. Okay, you're sending on the chat window. How do you ensure, okay, I'm reading it for everyone. How do you ensure the quality and reliability of EV generated data when transforming it into actionable insights, especially considering variability across different vehicle platforms and environment? Okay, there is some other question as well.
Please give insight on it.
Okay.
I'll ask them later.
Okay, so first thing is we are not actually generating the EV data on our own. We are using the data that is being provided by the Australian Transportation Government Department. So the EV generated data, one thing is EV generates the data that has some privacy concerns. So we are using the mobility data only at this point. The quality and reliability of the data, if we are looking into the detail of that, there are some concerns that of course need to be addressed well before taking into consideration of that data. the privacy and the other quality concerns. However, if we work on the mobility part and the energy emission and the consumption and how much the energy is being consumed from the grid by a vehicle in a specific time, there isn't any quality issue in that part. Reliability, as I said, so because of this factor, we are using the government produced data set, and I hope this answers your question. One part more, different vehicle platforms and environments. So now, at this point of time, the EV platforms and the environments are under of what we say, like systematic working is going on for the environments, vehicle platforms and environments. There isn't any cross-platform integration available yet. So we hope that this also comes in future, and then we would be able to discover this point as well. Yeah. Thank you.
Thank you so much, Dr. Asma. Thank you so much, and thank you all the audience for the detailed discussions. Thank you so much.
Thank you so much. Again, I would like to extend my thanks to all IEC team, to organization team on working on this one and inviting me. I hope you guys have a wonderful conference ahead and all the talks and the presentations.